Part C. This is the part where we start to use our inverse normal distribution. What is the IQR? So it's been a while since we've talked about your interquartile range, but hopefully we remember that an interquartile range is equal to your third quartile minus your first quartile. And then we have to remember what quartiles mean in regards to the percentage that it represents. So we remember our box and whisker plot. And then remember that your box and whisker plot divided your entire space into 4 sections. And each of these sections represents 25% of your data. Which means that quartile 1 is actually your 25th percentile. So we're going to say, hey, given 25% of your data, what's the value? So if we were talking about this bell curve, we would want 25%. So if this is 50, I didn't draw this picture very well, but it's the idea of we want to figure out, well, what is that percentage of the total values or the total probabilities? Quartile 3 is our 75th percentile. So this is our 25th percentile. This is our 75th percentile. So if we want to find our interquartile range, we need to find out what is our 75th percentile and what value corresponds to our 25th percentile, and then we subtract them out. So we first need to find quartile 3, quartile 1, and then we can find our IQR. Okay, so now we're going to go to our inverse normal distribution. It's in our distribution part of our probability. Right below normal CDF is inverse normal. So I'm going to go ahead and click on that. If you have a TI-84 and you can't figure it out on your own, definitely let me know. But remember, it's your responsibility to just, it takes 2 minutes. Just go Google it and see what happens. Okay, so your area underneath your curve, your area is your probability. So your area is just 0.75. It cannot be 75. It has to be 0.75. And then you just put in your mean, which is still 135, and then your standard deviation, which is 4. And I get a value for my quartile 3 of 137.69795. I'm going to go ahead and put down 137.7 because I'm just going to write it down to remember that that's the number, but I do know that I need to grab my exact values from my calculator in order to calculate this. So moving on to quartile 1, my area underneath, my area for this guy should be 0.25. Go ahead and find what quartile 1 is. Going to our probability distributions and clicking on inverse normal, we put in 0.25, 135, and then and then 4. So we should have gotten 132.3. So then our final step here to calculate our interquartile range is to subtract those two values from each other. Make sure to grab your exact values. So we're going to grab the exact 137 by clicking enter, the exact 132 by clicking enter. Make sure to put a subtraction in between before you do that. And you should get a total of 5.395. 3 sig figs would be 5.40. Remember that our measurements, our units of measure, are minutes. So your interquartile range is 5.40 minutes. So what does that mean? What does that mean in the context of this problem? If I was like, hey, interpret your interquartile range in the context of the problem. That means, remember that your interquartile range represents 50% of your data around the median. So that means that 50% of your data are in this range of 5.40. Realize that your standard deviation, your normal distribution is focused around the mean and not the median. But because it's symmetric about the axis, if you remember our skewed data situation, remember that it means that if it's symmetric, completely normally distributed, it means that your mean and your median are the same, which means that 50% of your data is within 5.4 minutes on either side. It means that this whole distance is 5.4 minutes. Which means it's pretty clustered. If you're talking about 135 being your average, that's a pretty small standard deviation and then that's a really small and corresponding interquartile range, which means you're really clustered, is the big picture there. Okay, 5% of the trips take longer than a certain time. If you're talking about 5% of your trips take longer, realize that your inverse function only does less than. It doesn't do more than. So we had to find quartile 3, and it found a value of up to our 75th percentile. So we want to talk about trips that take longer than 5%. So if this is our top 5%, what we're really talking about here is not our 5th percentile, because our 5th percentile would be down here. We're talking about our 95th percentile. So keep that in mind. That percentiles talk about everything below that point. So if we're talking about the top 5% or the top 15%, you have to subtract that from 100. So the top 5% would be 95th percentile. The top 15% would be the 85th percentile. So you have to make sure to keep that in mind. So keeping that in mind, what is going to be the area that we plug into our calculator? 0.95 is what you should be plugging into your calculator in order to calculate for this probability. So now go ahead and solve for t. There's a lot of different ways that you could have answered this. First of all, in minutes, your answer would have been to 3 significant figures, 142 minutes. If you take your exact value and want to convert it back into the way that the measurements were given to you originally, this many hours and this many minutes, you multiply this by 60 and you get 2.36 hours, which is not quite what we were given. We were given 2 hours and this many minutes. So if I want to calculate 0.36 as minutes, I would do that's 2 hours, and I would take the 0.3597 and multiply that by 60 and get 2 hours and 22 minutes. So if you wanted to give it back in the way that they gave it to you, that would be how you would do that. Okay, let's go ahead and move on to our last problem. Our last problem is pretty much exactly like one of our problems that we did on the other side. So I would like for you to go ahead and see if you can solve it on your own. Go ahead and fill in the blank. All right, so here's the deal. We have an average of 821 grams. We have a standard deviation of 40 grams. We want the heaviest 8%. Which means we're talking about the 92nd percentile. So our area is going to be 0.92, and then you plug in your rest of your values. Then that means that the cauliflowers that weigh over 877 grams would be classified as oversized. Don't just put 877 like I just did. What you filled in your blank on the PlayPosit is how you should be wording your answer, because it says that find the range of weights of cauliflowers classified as oversized. So you need to say greater than or equal to 877 in order to be fully correct here. Okay, hopefully this makes sense. If not, you have time in class the next time we see each other to ask all the questions about the inverse normal. So this is just taking your input and your output. Instead of being given a value and asked to find a probability, we're now given a probability, but mostly given a percentage. As you've noticed from these problems, we're normally given like, hey, the top this percent or the bottom this percent. Find the value that corresponds to that. So now we're talking about being given a percentage or probability and then finding the value that goes with that. Yeah, okay, that's it. That's everything. Good job.